Night 2, we're going to look at stoichiometric calculations. And this is ideal stoichiometric calculations because we have to assume that these are under ideal conditions. Now, what does that mean? So, if we are carrying out a reaction, just like when we're cooking, if you're making cookies, you don't scrape 100% of the cookie dough into the cookies. There's always a little bit left in the bowl. Um, the same kind of thing might happen with a reaction. Maybe not everything reacts 100%. Maybe some products of gas escape. So you aren't able to, in real life, always measure everything exactly like the theoretical, ideal world reactions on paper seem like they would occur. So when we do these calculations, though, we are going to pretend that they are going to react ideally and fully carry out through. So the first thing that we have to do is we have to balance our equations. So I'm going to do a little bit of that for you because at this point, hopefully you have a pretty good understanding of balancing the equations. So with this reaction, we just need a 2 in front of the LiOH, and that's going to give us a balanced equation. So then the first thing, we're going to read the equation or read the problem, how many moles of lithium hydroxide, and we have to be able to identify some of these names with some of the formulas. So lithium hydroxide, remember, is LiOH. How many moles of those are required to react with 20 moles of CO2? So we're looking at these two substances in a reaction. They might give us a product and reactant, two products, but these are the two they picked out. So what they have given us with the number, that's what we're going to start with. So 20 moles of CO2. And we're looking for moles of lithium. It's going to be very important that you use your units and write those down as we do our conversions because there's going to be a lot of things switching around in these stoichiometry problems. So we've got 20 moles of CO2. So then we're going to do our multiplying line. What we start with always goes on bottom in the next step. So moles of CO2. If we have moles of something on bottom, now we can switch to moles of another substance. That's the only time, is moles of one substance to moles of what we're looking for. So the formula for the lithium hydroxide was the LiOH. And here we're going to use our molar ratio. So we'll come and look at the coefficients. So the coefficient for LiOH is 2, and for CO2 is that understood 1. So we were looking for moles of lithium hydroxide, and that's what we have on top in the last step. So now we're ready to calculate. So remember, if we have a number on top, we multiply. Whatever is on bottom, we divide. So here we just have 20 times 2, or 40 moles of the lithium hydroxide is our answer. Let's look at the next one. So for this balanced equation, we would need to have a 4, and then this would be a 1, and this is going to be a 2. So our problem says how many moles of lithium oxide, so that's this guy right here, will form if we have 2 moles of lithium reacting, so this. So we're starting with what they tell us, 2 moles of lithium. And make sure you write those formulas just how they have them in the reaction because that's going to be important. So what we start with, moles of lithium on bottom. And since we have moles of a substance, now we can switch to moles of our second substance. So moles of what we're looking for, lithium oxide, which is that Li2O. And now we're ready to look at our coefficients. So Li2O is a 2 and Li is a 4. And so now we're ready to solve. 2 times 2 divided by 4 gives me 1 mole of lithium oxide for my answer. These mole problems are just one step and they're not too difficult. Always before we said when you're writing these moles out, you would get a 1. With your molar ratio, you don't. You would have something different with 1. Here we have 2 H2O2 is going to produce 2 waters and 1 oxygen. How many moles of O2, so we're looking for the O2, will result from the decomposition of 5 moles of hydrogen peroxide? And this is our hydrogen peroxide. So we'll write 5 moles of H2O2, and then we want moles of H2O2 on bottom. And we're going to moles of O2, so that's going to go on top. And so our ratio is 1 to 2. So 5 divided by 2 gives me 2.5 moles of O2 for my answer. The next step, we're going to look at comparing moles of one substance to grams of the other, or maybe we'll start with grams of one and we'll go to moles of that second. Now, when we did mole and gram conversions before, remember 1 mole is equal to the mass in grams of a substance. So we're going to have to look up some masses on the periodic table. And remember, we're using these bottom numbers here when we are calculating whatever the masses are for different substances. Okay, so again, make sure your equation is balanced. So we need this to be a 6, 6, 1, and 6. And this says convert 3 moles of water. So we'll go ahead and write that down. 3 moles of H2O. So we're dealing with this. To grams of C6H12O6. So we're looking at this guy right here. But now we're looking at grams instead of moles like we were looking at before. So we'll go ahead and get started. So again, whatever you have to begin with goes on bottom in the next step. So moles of H2. We have water, we're trying to get to sugar. So since we have moles of water, we can now switch to moles of the C6H12O6. We cannot go moles of water to grams of sugar. We have to go moles to moles. We have to use that molar ratio. So this was 1, and then this is 6. Now we've got another step because we're not done. We're looking for grams. Moles are on top. So since moles of sugar are on top, we're going to put moles of sugar on bottom, C6H12O6. If we have moles of sugar, now we can go to grams of sugar, C6H12O6. And we know that 1 mole of sugar is going to be equal to the mass of sugar. Now you'll have to add up 6 carbons plus 12 hydrogens plus 6 oxygens like we've done before, but I've already done that, and that's 180. Since grams of C6H12O6 is what we're looking for, and it's in this last step, now we're ready to solve. So we're going to take 3 times the 180 divided by the 6, because the 6 is on bottom. 1s we don't have to worry about because they cancel out anyway. And that's going to give us an answer of 90 grams of C6H12O6 for our answer. So this was a 2-step. Anything that's going to start with a mole and end with grams of something else, or start with grams of something and end with moles of something else, will have 2 steps in it. The mole to mole had 1. Okay, same equation. So we'll go ahead and balance that again. Here we're asking, what is the mass of carbon dioxide? So we're looking with carbon dioxide in grams. So we're going to look for grams of carbon dioxide. Anytime they say mass, they mean grams. Is needed to react with 3 moles of water. So we're going to convert from moles of water to grams of carbon dioxide. So moles of water go on bottom because that's what we have here. And now since we have moles of something on bottom, we can go to moles of our other substance, so carbon dioxide, and this is a 6. And where's my water? 6 there. So now we've got moles of carbon dioxide on top, so moles of carbon dioxide on bottom to grams of carbon dioxide. 1 mole for the mass of carbon dioxide, and carbon dioxide is 44. So now we're going to do 3 times 6 times 44 divided by 6. And that's going to give me 132 grams of CO2. We've got a new reaction we're going to look at here. We've got now 4, let's see, 4, and then 5, 4, and 6. This says convert 824 grams of NH3. So now we're going to start with grams. So 824 grams of NH3. And we're going to moles of NO. So we're using this one, or using this one. So since we've got grams of NH3, that's going to go on bottom. We can't switch to the other substance until our first substance is in moles. So we're going to have to get this in moles first. So grams to moles of NH3. 1 mole is whatever the mass of NH3 is, and NH3 is going to be 17 because we've got 14 plus 3 hydrogens gives us 17. Now moles of NH3 is on top, so moles of NH3 on bottom. Now we can switch to moles of our other substance, so moles of NO. So if we look, NH3, we've got 4 of those, and we've got 4 NOs. And moles of NO is what we're looking for, so we're ready to solve. So I've got 824 times 4 divided by 17 divided by 4. Don't go 824 times 4 divided by 17 times 4. Anything that's on bottom, you're going to have to hit divide first. And this is going to give me 48.47 moles of NO. Now we're going to look at mass to mass problems. So these are going to be 3-step, where we've done 1 and 2-step. Now we'll do 3. So again, we need to balance our equation. We need a 1 here, a 2, and then the rest are 1s. So this says how many grams of SnF2 are produced from the reaction of 30 grams of HS, or HF with Sn. So we're starting out with 30 grams of HF. And we're looking for grams of SnF2. So this one and this one. So since grams of HF is what we start with, that goes on the bottom. So we can't switch that yet. So we're going to have to do grams to moles of HF. And the mass of HF is going to be 20, so 1. We've got moles of HF on the top, so that needs to go on bottom. Now we can switch to our other substance, so moles of, and we're looking for SnF2. So here's going to be our ratio. So SnF2 was a 1, HF is a 2. We have moles of SnF2, so that's going to go on bottom. And now we're looking for grams of SnF2. So 1 mole with the gram, and this mass is 156.7. So now we're ready to solve. 30 times the 156.7 divided by 20 divided by 2 is going to give me 117.53 grams of SnF2. And that's my answer. Every one of these problems, whether it's the mole to mole, or just the 2-step or this 3-step, you're always going to have a step that's mole of one substance over a mole of another, where you're having your molar ratio. What you're starting with will be on the bottom, what you're going to will be on the top. Anything before this will either be your original substance in moles or getting it to moles so you can get to this step. Anything after this will either be stopping there because you want moles or getting it to grams because you're looking for grams of that second substance. So this step here, that molar ratio, is going to be kind of the switching point for your reactions. All right, we'll see what we can do.